A common requirement when creating a system that requires communication between lots of different objects is limiting communication to specific objects only. Mapped to our system, we could say we want to support functionality in which a team member can choose to only communicate with a specific person by name or another member from the same type. For example, lawyers that only want to chat with lawyers and don't want their messages to be delivered to account managers and vice versa. That's what we'll implement in this demo. We'll start with the first scenario, sending messages to a specific person. In the previous demo, we decided that we would use the name as key for the dictionary, making it unique. We can use that same name to select the person to send the message to. So the first thing we need is a method that accepts this parameter on the mediator. And then we need to implement this on the concrete mediator. That is our team chat room. Let's implement the interface. And here's the method we need to implement. We want to send a message to a specific team member, and seeing that team members is a dictionary which stores team members with name as key, we use the dictionary indexer to get the correct team member. If it's not null, we call receive on it. With that, we have ensured that only the correct team member will receive a message. What's left now is ensuring that a team member can send such a message. So let's scroll up a bit to the team member abstract base class and add an additional method on it. A send method that accepts a toString. The only thing that this method does is pass it through to the send method we just implemented on our chat room. And that's it already. Let's test this. Let's say we want to have Sven send a message to Anne to jump on a Teams call to talk about the file he's checking. Let's give that a try. And there we go. That last message we sent was only delivered to Anne. So far, so good. Another useful scenario would be sending a message to all team members of a specific type. Let's do that next. The implementation is not that different from what we just did, save for the fact that we can use some generics for that, which is why I'd like to show it. The first thing we need is another method on our chat room. We want to pass through a type, lawyer or account manager. We can use generics for that. The type must derive from the team member class, so we pass that as a restriction. That's it for the adjustment to our interface. On to the implementation. Let's implement the interface. We see that we need to implement one additional method. In this method, we want to run through all team members of a specific type. And the type they are of, that's T, the type that's passed through. So that's exactly what we do. We get all values of type T from our dictionary, and we let them receive the message. All that's left is one more method on our abstract team member base class. Just like we added a method to send a message to a specific person, we now add a method to send a message to a specific type, which calls into the send method on the underlying chat room. And that's it. Let's give that a try. Once Sven lets Anne know that the file is good to go, Anne wants to communicate this to all other account managers. She can use the send-to method passing through account manager as type for that. Let's give that a try. And there we go. After Sven sent the message to Anne, Anne sends the message to all other account managers. As we can see, that means that the message was received 3 times. That's it for our demo. Let's continue by checking out a popular implementation of this pattern, Mediate R. What we're looking at right now is Mediate R, a very popular .NET implementation of the mediator pattern made by Jimmy Bogart, the guy who also made AutoMapper. This project is on NuGet and it supports request response, commands, queries, notifications and events, synchronous and asynchronous, with intelligent dispatching via C# generic variants. The way Jimmy implemented it does differ from our pattern implementation. Ours is closer to the original design. But that's okay. As mentioned a few times, pattern implementations can and will differ. As long as the principles and the intent remain the same, that's okay. And that is the case with Mediate R. With that, let's have a look at the main use cases for this pattern. There's 3 good use cases when applying this pattern is something to consider. First, when a set of objects communicate in well-defined but complex ways, which results in interdependencies that are unstructured and difficult to understand. 2, when, because an object refers to and communicates with many other objects, it's difficult to reuse. In other words, when you've got tight coupling between a set of likewise classes. Both of these apply to our real-life chatroom example. And lastly, when behavior that's distributed between several classes should be customizable without a lot of subclassing. In that case, the mediator pattern can avoid a lot of that subclassing. What this means is that the mediator localizes behavior that would otherwise have to be distributed amongst different classes. And it does that because all relations between components are contained within the mediator. From that follows that when using the mediator, the colleague classes can be reused as is when the behavior has to be customized. It's contained within the mediator without requiring changes to or subclassing of the colleague classes. Let's continue with the pattern consequences. There's 5 important potential consequences to this pattern. First of all, as we just detailed as last use case in the previous clip, it limits subclassing. A second consequence is that it decouples colleagues. Thanks to the mediator, they are now loosely coupled instead of requiring the colleagues to know about each other. It also simplifies object protocols. What's meant by that is that interactions between objects that would normally be many-to-many interactions are replaced with one-to-many interactions between the mediator and its colleagues. These are simpler to maintain, extend, or understand. The open-closed principle also applies. New mediators can be introduced without having to change the components. And lastly, a disadvantage. Mediator centralizes control, which, as a consequence, can make the mediator complex. That is a disadvantage because it could turn your mediator in a monolith that's hard to maintain. Before we go to the summary, let's check out the related patterns. The first related pattern is a structural one, the facade pattern. Both mediator and facade organize collaboration between a lot of normally tightly coupled classes. But there are differences. Mediator, like facade, abstracts functionality of existing classes. But it's not the same. The purpose of the mediator is abstracting communication between objects, often centralizing functionality that doesn't belong in those objects. Facade, on the other hand, simply abstracts the interface to the subsystem objects to promote ease of use. When we look at some of the other patterns in this course, we find others that connect senders and receivers of requests. In that regard, chain of responsibility, command, mediator, and observer are all related. If you watched the module in which we tackled the command pattern, you probably remember this slide. Chain of responsibility passes a request along a chain of receivers that can be defined at runtime until at least one handles it. Command connects senders with receivers unidirectionally. For example, from a button that's pushed in a UI to the action that finally gets executed. The mediator pattern, as we've just learned, eliminates direct connections altogether. Communication runs through that mediator. And lastly, the observer allows receivers of requests to subscribe and unsubscribe to them at runtime. Let's check out the module summary. We looked into the mediator pattern in this module. The intent of the mediator pattern is to define an object that encapsulates how a set of objects interact. It promotes loose coupling by keeping objects from referring to each other explicitly, and it lets you vary their interaction independently. When implementing it, think about encapsulation. Use an internal method to ensure that the mediator can't be set outside of an assembly. Also, don't allow overriding methods when it's not needed, like the send method, as that would add unnecessary complexity. Up next is the chain of responsibility pattern.